Hey, welcome to the lecture on Introduction to Basic Probability. So what is a probability? Probability is a measure, think of a number, that is associated to how certain we are of outcomes of a particular experiment or event A. So we typically denote experiments or events with capital letters at the beginning of the alphabet. Probabilities can be any number between 0 and 1 inclusive. So that means it could be 0 and it could be 1 and plus all the numbers in the middle. And for notation, we write capital P for probability of A for the probability of A. So in terms of the measure, the count, the number that we associate to a probability, if the probability of an event A is 0, then that means it's impossible or that it cannot happen. On the other hand, if we have the probability of A is equal to 1, then that means it's certain to happen or it always happens. If your probability of A is 0.5, that's the same as 50%, 0.5. So this is the same as 50-50 chance, meaning that event A is equally likely to happen or not happen. If your probability is high, close to 1, like say 0.9, that's the same as 90%. So probability of A equaling 0.9 means that event A is 90% likely to happen. And it means that it's 10% likely to not happen. And so this is a little foreshadowing for a later topic about complements. So let's consider the following probabilities for an event A. Are all of them valid? So for the first one, probability of A is 0.22. This is fine. This is a number between 0 and 1, and this makes sense. In the second one, probability of A is negative 0.30. So we cannot have anything outside of 0 to 1. And that, if you're below 0, then you're negative. So this is not a valid probability. In the third bullet point, probability of A equals 1.00. This is fine. We can have something as 1. But in the fourth bullet point, 1.99, we can never go over 1. So this is not a valid probability. Probabilities for equally likely events are set up as a basic fraction. Equally likely events means that each outcome of an experiment occurs with equal likelihood. And the way that you set up your fraction is you take the number of favorable outcomes and you divide it by the total number of possible equally likely outcomes. So let's consider this example. What is the probability of getting tails when flipping a fair coin? So the thing that we want, the favorable outcome, the thing that we're looking for, the thing that we want to measure is getting tails. So that's going to be the numerator for our fraction, the number of tails. And we can see here in this picture that there's only one side of the coin that is tails. So if I'm setting up my fraction, the probability of tails is going to be 1 over something. Okay, well, the denominator has to be the total number of things that can happen. Well, there's 2 things that can happen. You can see here in the picture, I could get heads or I could get tails. So it's going to be 1 over the total number of things that can happen, 1 over 2. But you already knew the probability of getting tails was 1/2. But hopefully this example shows you how to set up your fraction with a concept that's already familiar to you. Here's another hopefully familiar concept, rolling a 6-sided die. So here we're going to roll or try to roll an odd number on a 6-sided die. So odd number, that's going to be our favorable outcome. So when we set up our fraction, we're going to do the number of odd numbers divided by the total number of things that can happen. So the probability of being odd, we have to determine how many of these faces on the die are odd. And you can see that there are 3, the 1, the 3, and the 5. So I have 3 odd faces. And I want to divide that by the total number of things that can happen, which is 6. So that 1, 2, 3, 4, 5, or 6. And when you're answering this question in your homework or on a test or in real life, whatever, you want to reduce your fraction. So make sure to write your probability of rolling an odd is equal to 1/2. In this next example, we have a yes or no survey. A group of people were asked if they had run a red light in the last year. 393 responded yes, and 421 responded no. And we want to know what are the probabilities for each response. Here, we're not given a total. We just have the number of people who responded yes and the number of people who responded no. So our first thing that we need to do is we need to figure out what our total is. The way that we would do that is going to be adding the responses together. Total number of yes plus the total number of no. That's going to give us the total in our denominator for the probability. So I want to add 393 to 421, and my total is going to be 814. So for probability of yes, number of yes divided by total. We have 393 yeses, and we have 814 total. So it'll be 393 over 814. And we're going to round this to 4 decimal places. So I get 0.4828. And then for no, it's going to be the number of people who said no divided by the total. So that's going to be 421 divided by 814, and then round it to the nearest, round it to the 4th decimal place. In this example, pennies and nickels, a bowl contains 20 pennies and 17 nickels. We're going to reach into the bowl and pull out one item. And we want to know what's the probability of getting a penny or probability of getting a nickel. So again, this is very similar to the yes-no survey. In order to determine the probability of getting a penny, it's going to be the number of pennies divided by the total number of coins. And so we need to know the total number of coins. So that's pennies plus nickels, 20 plus 17, giving us 37 for our total. So now that we have our total, we can set up our fraction. The number of pennies is 20, and our total is 37. So this fraction is going to be 20 over 37. And here we're rounding to 4 decimal places. We get 0.5405. The nickel is very similar. It's going to be the number of nickels divided by the total. So that's 17 over 37. We're going to get 0.4595. Here's a bonus question. What would be the probability of getting a quarter? And you might think, what is this lady talking about? There are no quarters in this bowl. And actually, that right there is the answer. There are no quarters in this bowl. This question has nothing to do with quarters. So it's impossible. It would be impossible to pull a quarter out of a bowl that contains only pennies and nickels. And if you remember from the very beginning of the video, we said things that are impossible have a probability of 0. So to answer the question, what's the probability of pulling out a quarter? The answer is 0. There are no quarters. This is impossible.